own research and you're designing your own experiments. So we're just going to kind of hit the high points and just kind of get the basics down of what it means to really fully design an experiment, but it's not something that we spend the rest of our time on. So there's some new vocabulary terms for section 1.6. The first one is a factor. The factor is the explanatory variable. It's what you are testing. So what are you testing? Are you testing different food, different fertilizer, a new medication, a new shampoo? What are you testing? And then you have the treatment, which is what you're going to be doing to those individuals. What is the treatment? And the treatment is being done on what they call a unit, an experimental unit, which are the individuals participating in the experiment. Could be a person, an object, an animal. These are also referred to as the subjects. So the units are the subjects of your experiment. Victims, maybe, is a word, depending on the type of experiment being done. And then you have, most of the time, not all of the time, you have what's called a control group. It is a baseline treatment. Sometimes they'll have no treatment. Sometimes they'll use the old treatment. So if you're testing a new type of dog food, you might have the old dog food as a control. So it's their baseline treatment. And sometimes it uses something called a placebo. A placebo is a fake medication. Fake pill, fake shot, fake medication. It's to help humans, really, from knowing whether or not they really got the treatment or if they got a fake medication. So a placebo is only necessary for human subjects. Dogs don't need fake medication. They either take it or they don't, and they don't care either way. But sometimes humans will act different if they know they had a medication or they did not have the medication. So they use a placebo to make them think they had the medication to help distinguish the results and have it not be based on their perception of taking medication. So placebos are sometimes used. Finally, we have blinding. Blinding is a technique used so that the subject does not know which treatment they are receiving. Again, this is really only necessary for human subjects. Blinding is where a placebo would come in. So I'm giving you this medication and you don't know if it really is the medication or if it's fake. You can do blinding without a placebo, but generally a placebo is involved. And then you have something called double blind. Double blind is very important sometimes. This is when the subject or the administrator does not know which treatment is being received. It's generally necessary when a product is trying to be sold or purchased. So if a pharmaceutical company is trying to push their product on a doctor's office, it's important that no one knows who got what. A third party can know, but not someone who's trying to sell something or buy something. It's important for double blinding to be used. So there's different types of experimental designs. Again, not something we go too far into. One of the most common ones is called completely randomized. So in this situation, a farmer wishes to determine the optimum level of fertilizer on his crop to maximize his yield. So he has all his plants that he's going to do the treatments on. He separates them randomly into 3 groups. Group 1 gets 20 plants, Group 2 gets 20 plants, and Group 3, that's just randomly assigned. The first treatment is no fertilizer. The second treatment gets 2 teaspoons, and the third one gets 4 teaspoons. They measure their yield and compare them. Just totally random. The other common type is called a matched pairs test. This is important for human subjects. Also sometimes good for gardening and trying to grow crop. So in this example, does listening to music have an effect on a student's ability to learn? So some say music helps you learn, or maybe it deters from your learning. So in this situation, we're matching students according to gender and IQ. Gender and IQ are potential confounding variables. So they separate it and they match them up, female with female with similar IQs, male with male, similar IQs. Then they randomly assign a student from each pair to a treatment. So student A and B are paired up. One gets one treatment and one gets the other. So they assign that treatment to the matched pair, and then for the matched pair, they look at the difference in the scores on the exam. So together as a pair, they compare the results. They don't compare for everybody, it's just in that matched pair. This is a very specific type of running an experiment to really control for those confounding variables. All right, so here's an example of an experiment. So we'll read through the situation and then we'll kind of answer these questions about the different aspects of the experiment. So we have Lipitor, which is a cholesterol-lowering drug, and they're trying to study the effects of Lipitor on cardiovascular disease. They have these subjects, ages 40 to 75. They already have type 2 diabetes, but they do not have history of a cardiovascular disease. So it's a very specific population, very specific age group, with type 2 diabetes without prior heart disease. So a very specific group. It is a placebo-controlled, double-blind experiment, and the subjects either got Lipitor or a placebo, which for them they thought it was Lipitor. And they were followed for 4 years. The response variable was the occurrence of any major cardiovascular event. Did you have a heart attack? Did you have something major as a cardiovascular event? And they found that Lipitor significantly reduced the rate of major cardiovascular events. So those are those results from the experiment. So we're going to answer a few questions about that. It says, what does it mean for the experiment to be placebo-controlled? What does that mean? Then we're going to look at what does it mean for the experiment to be double-blind? What is the population for which the study applies? And what is the sample? Going back to those vocabulary words. What are the treatments? And what is the response variable? And it asks if it's qualitative or quantitative. So these are the types of questions you'll see in your homework to kind of break down a situation. So for part A, it says the placebo is a medication that looks, smells, and tastes like Lipitor. The placebo group serves as a baseline, and you don't have to be this detailed in your response. The book's just kind of explaining it all. This placebo is used because people tend to behave differently when they are in a study. So by having a placebo control group, the effect is neutralized. So it's a fake medication. Question B, what about double blind? So since the experiment is double blind, the subjects, as well as the individual monitoring the subjects, do not know which ones are getting Lipitor and which ones are getting the placebo. So it's double blind so that the subjects don't know and they don't behave differently, and the individual monitoring the subjects does not treat those with Lipitor group differently. So everybody's neutral here. Question C was about the population. So our population is very specific. Age with type 2 diabetes without prior heart disease. This sample was the 2,838 subjects that were chosen. The treatments are either Lipitor or a placebo. We're just pulling all of this information out of the situation. And finally, the response variable is whether or not the subject had a cardiovascular event. So it's a yes or no question. So it's qualitative. It's yes or no. So that hopefully that kind of puts together these different vocabulary terms and how they relate to a specific situation. All right, just about there. The last thing I want to go over is kind of the overall process and how to design an experiment. So the steps in designing an experiment. This is on page 47 of your textbook. I think this pulls everything together and kind of helps you see how this all fits. So again, this is on page 47 of your textbook. So our first, identify the problem or the claim, determine the response variable, which you're going to be measuring, and the population you're going to be studying. So just kind of get your basics down. And then determine the factors. This takes a lot of time to really think about what affects the response variable, what can be controlled, what can be varied, what are some things maybe you can't control. So really take your time to think about those different factors. You want to control as much as you can. And then we get to decide on our sample size. This is as many as we can afford, time and money and resources, as many as we can afford. Calculating an appropriate sample size we'll get to in Chapter 9. There's a technique for getting an appropriate sample size. But in general, you just want to get as many as you can afford. And then step 4, we decide on a level or an amount for each factor. Do we need a placebo? How are we going to vary this treatment? Are we going to have the old medication and the new medication? What is it that we're trying to work with? So we have to decide on those different levels for each factor. Then the fun part, we get to actually conduct the experiment. We always need randomization, replication, and control. Randomization is to reduce bias. I don't know if you can see that. It's to reduce bias. Let me write with a darker color. So if you randomize, kind of helps control your bias. That did not help at all. Replication is more than one. So you're not just going to have one test subject, you want a lot. And then again, control, we've talked about controlling those confounding variables. Then you get to collect and process your data. And finally, you get to answer the question using inferential statistics. So you get to generalize from your sample to the population you are studying. So you get to have your conclusions from testing your claim. So that kind of puts everything in Chapter 1 together. And that is everything you need to know from Chapter 1.